This is Killer Innovations, a show about ideas, creativity, and how you can innovate. Welcome to the Innovator's Garage, where you learn to create your next game-changing killer innovation.
Welcome to Killer Innovations. I'm your host, Phil McKinney. We are here in the studio in northern Colorado. We are still doing our COVID-19 isolation up here, but the weather in the springtime is here in Colorado. You can see the picture behind me if you're watching us on the YouTube channel with the view of Long's Peak over in Rocky Mountain National Park. And today we are going to have a pretty interesting conversation. As I've shared in the past, in a number of times, the guests that come on to this show, we get them into some areas or industries or expertise that I'm interested in, but quite honestly, not in my technical background. Today's a little bit different because we're going to talk about 3D printing. And given my background and role when I was at HP and HP's investment in both just basic printing technologies, but moving into the 3D printing, this is actually a topic that I am actually personally interested in. I'm not a 3D printer guy from a technical or a science background, but this is an area that I think is going to be pretty transformative for all of us. And we're seeing some of that manifest itself when you look at the 3D printing industry and even hobbyists and their response to the COVID-19 activities and needs. It's been pretty impressive at how fast people can get self-organized when the need is there. So with that, let me bring on today's guest. Today's guest is Jonah Myerberg. Jonah is the CTO for Desktop Metal. Jonah, thanks for joining us here on Killer Innovations.
It's my pleasure. Great to be here, Phil. Thank you.
Thank you. So before we get jumped in on your company, Desktop Metal, give us a little bit of background because you have been in a lot of industries and a wide range of sciences. It's not like you've been a 3D printing guy forever, but you have a pretty interesting background. So give us a little history of yourself.
It's true. It's true. I'm a mechanical engineer by degree. I've always been a kind of customer of 3D printing and additive manufacturing as an engineer. I discovered 3D printing as a piece of the larger AM process. But I guess I've always been interested in making things, right? I grew up in West Virginia, and I always wanted to turn my lawnmower into a go-kart. I don't think I was unique there, but went off to college at Lehigh University and then Johns Hopkins University. And I purposely took my first job with Black & Decker making power tools, right? Another tool that you can do stuff with and work with. And I think the power tools are a great example of a piece of a larger industry, just like a sander or a cut saw is part of woodworking, right? It's part of this larger art. So then I went from Black & Decker up here to Boston, to where I am currently. Took a job with Bose Corporation, and Bose is a highly innovative, just an amazing company. I really feel like that's when I was exposed to some really amazing innovation with what Dr. Bose had been doing for the past 30, 40 years. Dr. Bose is an amazing innovator and an amazing engineer. And for, the past 24 years, he'd been designing a suspension system for a car. I mean, who knew? It was Bose. They make speakers. But no, I mean, he had this grand idea of how he was going to use his controls and linear motors that he used for speakers to control the suspension of a vehicle in a car. So that was an amazing experience at Bose. And then I was reintroduced to engineering and to Black & Decker through a company called A123 Systems, who was doing work with new batteries coming out of MIT. Mm-hmm. And my team at Black & Decker introduced me to my co-founder, Rick Fulop, who's now, my close friend. And we built up A123 Systems around a new battery technology. And then we took that through all of its paces, built that company up, to a huge manufacturer of batteries. And then we sold it, to a large Chinese conglomerate. So that was an exciting time in which we took, lithium ion batteries into areas that they've never been before. And then after that, I was, working with some of my customers they use these batteries, and then off to found Desktop Metal with Rick Fulop, who I met back in 2005.
Well, it's interesting. You were talking about Bose. I had the benefit of actually being up at Bose and getting a personal demonstration from Dr. Bose on the car suspension system. The old, drive it to the parking tie thing and having it stop and not having, it was a Lexus, right? Yeah, it was a Lexus. With the airbag, with the air. Well, he tells the story. He started off with he bought an old car that had air suspension systems, and then didn't like it and started playing around with it, and then drive right over the railroad or the parking barriers and all that, and having the car travel right over the top of it. I actually was friends with Vanu Bose.
Oh yeah, sure.
Right. So in fact. At HP, I was the sponsor for Vanu's FCC certification for his software-defined radio, which was his PhD project.
He's another amazing engineer.
Another amazing engineer, and unfortunately died way before his time. Both Dr. Bose and his son Vanu both. It was a sad loss for all of us when you've got, great minds like that. But I think Bose is also a great example of innovation because. What was it? He had 20 some years of research on this suspension system. What other company, what other organization commits to innovation on that kind of a long-term scale? We could have a whole separate conversation on, I believe the quarterly reporting requirements has been the worst enemy of innovation inside of organizations forever.
I tell you, it's an amazing story because he started that work in the 80s. When the mechanical technology didn't exist and when the computing power didn't exist. But he had this vision of the future when it would exist. And he developed it with that vision in mind. And sure enough, in the late 90s and early 2000s, he got his wish. He got the mechanical technology for the actuators, and he got his computing power for processing. And then he was able to demonstrate it on that Lexus that we would watch go around the parking lot.
Well, I think this does tie in a little bit to the 3D printing conversation, right? Because look, we've had printing for a long time, from the early bubble jets to the ink jets to laying down fluids. Then you start thinking about the ability to get to ultra high resolution, to microplacements, and et cetera. And then then it's the next logical question saying, well, could we put other materials through, quote, a nozzle or a print head? It's kind of, Dr. Bose saying, something, I'm going to believe in Moore's Law. I think Moore's Law is eventually going to get there. So if I get through another 6 or 7 cycles of Moore's Law, what kind of compute capability could I have and what could I do with that? We all tend to think in more near terms, right? It's like, what can I do now with what I can buy versus designing to what is going to be coming and have the confidence that it's going to be there. And I think 3D printing is another good example of that when you think about coming from, quote, traditional printing to getting to the point where we're talking about 3D today. You agree?
I agree completely. That's a great example. And it's all about what the technology can enable, right? The huge killer innovation doesn't need to be your invention, but your invention can then enable the next killer innovation.
Yeah, well, you're singing my song because the way I think about it is look, we're all in this innovation ecosystem together, and real innovators don't focus on the fact that they've got to do the whole stack. Leverage the best innovations in those elements that help you achieve that piece that you can contribute to. I think, I talk to so many, innovators that think they have to own everything in the stack, and they're not open to creative partnering or co-innovation work. And they don't think about themselves or even the work that they do could be a platform for others, or how to leverage other people's platforms to bring the innovations forward.
That's exactly right. And Bose is a great example company of where that's happened. And that work that Dr. Bose had done for the past, that 24-year period, it didn't result in a product that is now in the market. It resulted in an amazing, innovative suspension system. But where it was applied was something totally different. It was applied to the seat of tractor trailer trucks so that truckers going long distances could now ride on this air suspension. So it became something totally different than what he had expected, but amazingly successful and amazingly popular by long distance truckers.
Yeah, well, and I own a 45-foot Prevost luxury bus that has my studio in it, and it has it's a fully outfitted, and that's how my wife and I travel. And I have actually one of those seats in it, and it's fantastic it's fantastic when you're driving. And also the military used it too, right? They were using it, experimenting it with Humvees so they could go faster over very, very rough terrain. And an interesting story that I checked, Vanu told me this story and told me about his dad, Dr. Bose. When Vanu was growing up and all the way through teenagehood, Dr. Bose would not allow Vanu to have a stereo in his bedroom. So here's Vanu Bose as a kid, and his dad would not allow him to have a stereo, and his dad confirmed the story, which I thought was absolutely hilarious. With that, we're going to take a quick commercial break. When we come back, we're going to continue our conversation with Jonah Myerberg from Desktop Metal. Don't go anywhere. We'll be right back after this quick break. Welcome back to Killer Innovations. I'm your host, Phil McKinney. We are here in the studio, continuing our conversation with Jonah Myerberg from Desktop Metal. So, Jonah, as we were talking in the first segment, given your history, and it's kind of a little bit eclectic, your backgrounds, but it kind of has led you to where you are today. So give us a little background of what really prompted you and the team to come around this idea of the company Desktop Metal.
Sure. So as I mentioned before, Rick and I were designing batteries for industry, including the automotive industry. But where it became really popular was in motorsports industry, as we found ourselves developing these very high performance batteries for racing teams and working with those racing teams to win races. And one thing we noticed was how these racing teams were efficiently and effectively using 3D printing to optimize their performance. And so we thought, well, this is something that everyone needs to use, not just the elite racing teams. And we looked further into it. As a customer of metal 3D printing myself, as an engineer, I knew of the technologies, but it wasn't until you really dig deep into where and how they evolved, you saw that they were very applicable to industries like the medical and the aerospace industry, but less applicable to like the automotive industry. So therefore, you had automotive teams that were racing using them, but you didn't have companies like Ford or General Motors or BMW actively using 3D printing. And so we founded Desktop Metal to bring metal 3D printing into those industries, to make it accessible by everybody, not just the ones that could afford it, but the ones who wanted to use it, but it just didn't make sense yet.
So are you focused then specifically at the automotive, or is that just where you started and you're going into other industries also?
Yeah, it's interesting. What we found is that there are so many different industries that are attracted to 3D printing in one way or another. Automotive industry is just one great example. But consumer electronics use so many little metal parts and have to invest so heavily in single designs that metal 3D printing makes a huge impact on them, remaining flexible and evolving their designs to the next generation and changing quickly and fast. One industry that we didn't expect was the jewelry industry. I mean, the jewelry industry is a very high, difficult industry to manufacture little metal parts, and they would love to print precious metals like silvers and coppers and gold and platinum, and so that's hugely popular right now. So we're touching every industry that you can imagine right now that touches metal.
So here's always been throwing a little stone here in the conversation about metal 3D printing is fidelity and finishedness and readiness of the part coming out of 3D printing. So how do you address that from the standpoint of the critics that are out there that say, oh, it's more of the hobbyist thing rather than being something that could, seriously impact kind of supply chain or speed to market, those types of things?
Yeah, it's a common criticism, and it's a misconception also. So 3D printing was traditionally judged on the performance of the parts that are produced, and originally small little plastic parts were more for models, like looks like or fits like, but certainly not functional prototypes or functional models. I mean, when I was working at Black & Decker and we were prototyping the next power tool, there's no way we could run that power tool because it was built with 3D printed parts. But that's evolved now to fully functional, strong parts that can be exercised, can be stressed and used as a real part. So fidelity is certainly one aspect of it. You know, how flat is a surface? How small of a pixel can you build the part out of? But performance is a much bigger picture. It's how strong is that metal? How strong is that plastic or that polymer? And is the chemistry right? You know, can you build a stainless steel with the right chemistry that makes it heat treatable or hardenable or corrosion resistant to make sure that you maintain carbon levels and oxygen levels and the levels of all the other ingredients in that. So it's absolutely essential to create that functional part, but fidelity is just one piece of it.
Yeah, and you bring up a good point though, right? Because when people think about metal printing, they're thinking about metals, but a lot of some interesting work is in the polymers. It's in the other kinds of high performance materials, not just, you know, can I do aluminum or steel or whatever on the metal side of it. So how hard is it to like on the material side? You know, one of the things that I know in my previous life was trying to get materials qualified. How do you work with the material suppliers to make sure that their materials will work in these kinds of new 3D printing strategies? So talk us through that a little bit, because every month there's a new material that's now available to 3D, you know, high performance 3D printers. What's the challenge on that? How's that all done?
Yeah, it's a great challenge. I'll tell you, it's a bigger challenge if you introduce a new process like 3D printing with a new material and say, okay, not only do you need to qualify this new process, but also this new material.
Right.
And some 3D printing processes are like that. Some 3D printing processes require photoactive resins, and we just don't use photoactive resins to injection mold. And yet we're printing an injection molded part with this photoactive resin. So your properties are going to be different. So now you're asking the user to qualify or accept or digest two different things, new material and new process. So what we started with was existing materials, stainless steels that are well known and well used. And so engineers, you know, that build parts out of a 17.4 stainless steel or a 3/16 stainless steel, they know that material. And you say, okay, now I'm going to print that same exact material from a 3D printer instead of pouring it out of a casting or machining it out of a block. And now that's a lower hurdle to get over. It says, okay, now I'm qualifying a new process, but my material is the same.
Well, this is an interesting point, right? Because I think the approach you've taken is the approach that most innovators should. If you try to cause somebody who's going to adopt your innovation to have to adjust to too many variables simultaneously, it just creates all kinds of friction. In your case, you've picked and worked with materials that's already familiar within that industry segment. So that's one less variable they have to deal with. It's just the process of taking that material and producing a part that they can hold, test, certify, make sure it complies, you know, with their needs, correct?
That's correct. And in fact, Rick Fulop, my co-founder, and I, we lived through this in A123 Systems when we were developing a new lithium-ion battery for the new electric vehicle market. And, you know, companies like Tesla would come to us and say, hey, we're developing a new electric car. We need the best battery. And we'd introduce our battery. And I think the smartest thing that Tesla did was to not go with an A123 battery in their vehicle. They chose a Panasonic battery, a well-established battery. They didn't want to invent two things at once. They wanted to invent one and focus on a well-known, well-established technology behind it, the battery. And you know, we partnered with Fisker instead, another company that tried to invent a new electric car, and we were developing a new battery at the same time, and you know the history of that.
That's a perfect example. We're going to take another quick commercial break. When we come back, we're going to continue our conversation with Jonah, talking about 3D printing. Be right back. Welcome back to Innovations. We're continuing our conversation with Jonah Myerberg at Desktop Metal. Now, Jonah, one of the things that we've all seen in the press, particularly, you know, more recently, obviously, with regards to the benefits of 3D printing. But the more recent impact has been related to COVID-19. We've seen where everything from hobbyists to the large 3D printing organizations, companies, have all come together to make a variety of different parts and prototypes as we've tried to address a whole wide range of issues. And I know that you've been involved in a lot of those different programs. Tell us a little bit about 3D printing, COVID-19, and the things that you've been involved in specifically.
Sure. So one of the first things that Desktop Metal did back in March, as this all began to happen, is that we opened our doors and our technology. I mean, quite figuratively, of course. But we launched a website. We put out an email address, and we said, "What can we do to help you?" We were talking to all the hospitals, all the essential workers. What do you need? And then we sat back and we started to see it come in, and it poured in. And we started to see the shortage of swabs was a great example of an area where we were asked to help, and where my co-founder Rick Fulop really took it on his own to build out an organization of CEOs to handle that. We had requests come in from the VA hospital here for converters for their face masks to make scuba shields into face masks. There was this huge initiative that happened countrywide, I mean, really worldwide, where innovators were developing new types of ventilators. And so we wanted to support that. What could we do to help makers and small companies innovate and make new types of ventilators? And so we started working with those and hospitals who were going to use those ventilators or had a ventilator shortage. What could we do to help them? And then we just, we had some amazingly creative doctors and innovators ask us to print parts that they had engineered for their help in the office. And so we helped them to do that.
Yeah, and I mean, and the fact is, I think opening up your platform and making it easy for people to interact with you in these kinds of crises has really shown. You have provided us with some images here. I'd like to walk through some of these. This image that you sent me, and if you're on audio, you're going to have to hop over and catch the images over on the website. We'll post them there. But this is the ability to scale up the swabs being so critically important for scaling up testing to be able to get enough tests for COVID-19. Walk us through this. What are we seeing here?
Yeah, so we were really curious as to whether we could help manufacture these swabs through 3D printing, because there's such a shortage. I mean, you need 10 million of these swabs a day to start to produce the tests that are necessary to really turn things back on in this world, especially and just in this country. So the swab is an incredibly complex little device. I mean, it has this little bristly tip that it's used to collect the specimen, but then it has this handle that is engineered to collect the specimen, but then break off into the vial for collection. And then it has this neck that's supposed to bend to get back behind the nasal cavity and collect what it needs to collect. That is traditionally made without 3D printing, right? It's like a nylon bristled little head. And when you look at it first, you say that's not 3D printable. There's nothing that we could do there. But when we got all of the companies together and we said, how do we address this? The first thing that we did was to redesign that swab. And a lot of these companies figured out how to design that collection device at the tip so that it could be 3D printed effectively and efficiently, and then useful in a material that was bendable, that would go behind the nasal cavity and could also snap off.
And what material is it made out of?
So it's funny. It's made out of various materials by the different companies who have agreed to print it. And there's two major companies that are participating in this right now, Form Labs and Carbon. And they both are really materials manufacturers themselves. Sure, they make these amazing 3D printers that they use as their photoactive resin to grow parts. But they develop that resin, and they develop for many different applications, including medically and biocompatible materials. And they've never printed swabs before, but it was very easy for them to transition into that with these materials that were biocompatible and flexible.
Interesting. The other example that you gave, and I'm going to assume that this is the picture we're talking about, and this is using the scuba mask then to make it as a PPE for, for doctors. So you basically converting a full face mask for scuba to protect frontline workers. Talk us through this.
Yeah, it's a great innovation that actually came from the doctors, from the front line. And these are doctors who are dealing with potentially infected patients all the time, and they are running out of PPE. They're running out of masks or hoods, and they're looking for alternatives. And they look in their garage, they look in their own garage, and they say, hey, I've got a scuba mask. I wonder if I could use this in the lab. And then they determine that they have some filters that they use for other pieces of equipment. And they say, if I could just attach that filter to my scuba mask. And if you go to the next picture, you'll see exactly what they have been doing. They asked us to design and provide a converter that would take a common commodity HEPA filter, something that was on the order of the N95 or better, and connect it to their face mask. And by doing that, they now had a reusable piece of facial protection that would protect them in the office.
Interesting. And so in this case, you're printing that piece that's just to the left there, right? Is that the piece you're...
That's right. Yes, and if you go to the next picture, you will see just that piece.
Okay.
And so this was what the doctors asked for. This is what the doctors envisioned in their head. They said, if I could only have this, but it doesn't exist. No one's attached a filter to a scuba mask before. But this is how 3D printing is so valuable. It's flexible. It doesn't anticipate a single solution. It tries to be as flexible and as agile as possible by trying to anticipate any solution. And so whatever the doctor has as the filter and whatever the doctor has as the scuba mask, 3D printing is able to create that mating piece.
And what were the reaction when I'm guessing that some people in the healthcare field were maybe a little skeptical that you were going to come up with an answer to this? So when you handed them the part, I could imagine what the reaction was.
Oh yeah, I mean the ideas were recognized as brilliant. Sure, sure, Doctor so and so, if you'd like to create your own scuba mask filter, that's great. But is it actually going to happen?
Right.
And then when the next day he walks in with it and it's working, you can imagine how it rapidly spread through the hospital, where other areas, other clinics were saying, hey, we need to get some scuba masks. We need to get them fast.
And then in the case, though, there was also other work that's being done in COVID-19 in the whole 3D printing community, with everybody making, their printers available, right?
That's right. So the 3D printing community came together, and if this was for what we were describing here, for doctors or for innovators who needed special pieces, or for hospitals that needed potentially larger supply of spare parts that weren't available. You can imagine these hospitals went looking for ventilators when they were short. They said, where are we going to find some? And they found them. And Mass General Hospital here in Boston went out and found a bunch of ventilators. They just couldn't find connectors for. So they came to us and said, could you make this connector? Because the supplier of this ventilator doesn't have the connector anymore, can't send it to us, or won't send it to us, but we have all these ventilators that we'd like to use. So we ended up printing them a number of these little adapter pieces that basically go into the ventilator and then attach to the oxygen hose that they require. And so that's it's a great example of them just coming to us with a need, and it didn't matter what it was. We'd never seen it before, and we were able to print it.
It's just absolutely impressive from the standpoint of how quick everybody responds. I always say, look, when the chips are down, human ingenuity will always win out, right? It's amazing how we can go solve problems when our back's against the wall. But in this case, also bringing people who probably don't have a lot of familiarity with the technology to even know to ask the question of, can you help us solve this? I don't know how you do it, but could you solve this? And then letting the best and brightest minds out there. We're going to take a quick commercial break. When we come back, we're going to continue our conversation with Jonah at Desktop Metal. Don't go anywhere. We'll be right back. Welcome back to Killer Innovations, continuing our conversation with Jonah Myerberg, Chief Technology Officer at Desktop Metal. Now, Jonah, we've been, as I look back on your career, you come from a wide range of different industries. And in some cases, yes, you described about doing batteries for the racing, and then you saw racing, how they did 3D printing, and you kind of, pushed you into a different area. But you've had such a wide-ranging career. If you were to sit down and you're going to coach and mentor maybe a new engineer coming in, just graduating, starting their career, or an innovator early in the process of coming up with an idea to create a business, what advice would you give them? What advice do you wish maybe you had starting out, kind of those lessons learned, or as we say in the innovation game, the scars earned in the process of making things real? What would be one or two pieces of advice you would give?
Right. No, it's a great question, especially for the young entrepreneur and inventor. And I always say dive in now. Dive into the river. There's a lot happening around us, and you need to be in there, swimming around with it to feel for those challenges. Mm-hmm. Don't be afraid to ask what's broken, what needs to be fixed, and don't be afraid to try to fix it. And don't be afraid to fail at fixing it, because no one fixed it on the first time. So keep trying, keep failing, and keep trying to help people. Everyone has a challenge that they're working on. There's real world issues going on right now that need innovative solutions. It's just a matter of going out there and putting your finger on the pulse and understanding what's going on, what could help. Learn broadly. Don't just focus yourself in one area. I always like to say that there are PhDs for everything, and you can use them at your disposal anytime you want. But if you want to truly be an innovator, go broad. Learn as many tools as you possibly can, and then combine them in new and clever ways. Innovation is not about digging deep into the physics and finding the newest solution. It's often as effective taking existing solutions, existing tools that have been developed over the years and applying them in different ways, completely foreign areas than they were born in. And you'll see, you'll bear fruit very quickly doing that.
Well, I think you bring up an interesting point, right? Because there's some people who kind of hesitate that says, well, there's this problem. There's but to solve that, I need to become an expert in X. And so therefore, I'm going to spend the next 5 years becoming that expert before I do the solution. And many people overlook the fact that in some cases, the best solutions don't come from the experts. They're not biased based on their background or education. In some cases, some of the more creative ideas that I've seen have come from people who have no background in the area of the problem.
That's absolutely right. Cross-functionality and cross-pollination of industries, taking something from, the industrial area and applying it into the medical area or vice versa.
Right.
This is where a lot of innovations come from, simply because the experts have already developed the solution. They just haven't applied it everywhere that it could apply. So don't reinvent the wheel, apply the wheel in other areas.
And you can always find the expertise that you need, right? You can go find, and I have found, I've made random phone calls to professors because they've written a paper. One, they're thrilled that somebody called them about their paper that they didn't think anybody read. And then two, they're more than willing to share with you what their expertise is, right? It's part of how the process works. Find the best expert. The other question I wanted to ask you real quick here is, those when I come across people who have been very successful in the innovation ecosystem, inventing across a wide range of technologies, the one thing that unique characteristic is curiosity. So what are you curious about now? not related to 3D printing. What's the thing that's kind of that's piqued your interest, that's kind of rattling around in that head? What's the new thing you're curious about?
Well, I think that the world and the country we're looking at becoming more efficient and becoming carbon. The goal is to become carbon neutral and reduce our dependency and our production of carbon gases. But what really interests me is to go beyond that. I think that to be successful in that, we need to become carbon negative. So what technologies are out there to really go over that line and say, not only are we going to become carbon neutral, or we're going to do things that are carbon neutral, but we're going to do things that are carbon negative. How can we do the same things we're doing now, but in a carbon negative way, absorb carbon from the atmosphere? And I think that is really where innovative technologies are going to come from, that are going to be widely accepted globally.
Oh, that is exciting. That is exciting. So, Jonah, if someone in the audience wants to follow up and keep track of what you're up to, what's the best place to keep track of the work you guys are doing?
Yeah, check us out on our website, www.desktopmetal.com, or on our social media pages. We love to post the news and the exciting things that we're doing. Just search for Desktop Metal, and you'll find us very easily.
Great, and we'll have all those links up on killerinnovations.com. Jonah, thanks a lot. Really appreciate you taking the time to join us here on Killer Innovations today.
My pleasure.
So as we wrap up today's show, just want to thank you for taking the time out of your busy schedule to join us. As you know, if you've been a listener for any time here of the show, we started this show back in 2005 as a way to pay it forward. It was a challenge given to me by my early mentor, Bob Davis. So we've been producing content now 15 years for all of you who've been the fans and followers and subscribers. If you are not a subscriber, I would encourage you to hop on over. You can subscribe to the YouTube channel, or you can subscribe to us wherever you get your podcast, and make sure you don't miss any upcoming episodes of the show. And so with that, also, I have one favor, though, to ask. If you find this content interesting, if you found this particular show of interest, and you know somebody who could really enjoy or benefit from hearing about these types of things, why don't you forward them the show, or invite them to subscribe, or tell them about the show? Helps us grow the subscriber base, helps us get the word out about what we're doing, and we're all part of the community. Which reminds me, if you're not part of the Innovators community, theinnovators.community, hop on over, free site. It's where innovators are hanging out, talking about ideas and things that they're working on. With that, stay safe, and we'll talk to you next week. Bye-bye.